Hello again. Well, I spent a little longer talking about reproduction than I thought. So here's video 3. I got cut off because I'm only allowed to do 15 minutes per video, which is probably a good rule anyway. So here's video number 3, and we were just starting the spawning aggregation video. So basically all it said so far was that the Nassau grouper is solitary for most of its lifetime until there's a winter full moon.
Solitary creatures, each inhabiting its own territory on the reef. But during the winter full moons, the fish gather to spawn.
Nassau grouper form absolutely massive spawning aggregations, historically in the tens to perhaps hundreds of thousands.
It's just really a natural phenomenon.
An age-old ritual. Their annual dance occurs at dusk. These days, spawning Nassau grouper have become a rare sight.
Primarily because of fishing at spawning aggregations, the numbers of Nassau grouper throughout the Caribbean have declined dramatically.
There's so few left that an aggregation of a couple thousand fish is about as large as it gets.
Any spawning aggregation should be protected because that's the only time of the year that fish actually reproduce.
Okay, if you want to watch the rest of the video, the link's down there, go for it. It's a great video. Okay, so we talked about we saw how fish can ensure that they're all doing broadcast spawning at the same time in the same place. These fish can come from all over the Cayman Islands to all be in that one same spawning aggregation. How do corals do it? Something called mass spawning. So, what happens is the adult corals all release sperm and eggs at the same time. Many different species all release eggs and sperm at the same time. And they rise to the surface, and then they start, they get fertilized, and they start becoming larvae, going through cleavage and everything. And then, again, those corals fall out. So, I unfortunately didn't get to actually go out and snorkel in the mass spawning on the Great Barrier Reef when I was there when I was in college, but I did definitely see this coral spawn washing ashore. I thought it was just oil, but it's actually coral eggs and sperm. Okay, so mass spawning is a synchronous release of gametes by many species of corals in one evening. So I think it's usually a full moon on the Great Barrier Reef. They discovered it in the late 70s or early 80s. And it's like one full moon in October. And they can actually predict it pretty far in advance. They can also do that with many of the corals in the Caribbean these days. So how the hell do corals do this? And you don't need to know this, but I always wanted to know. So it turns out they discovered they reported in a science paper just 2007 that a scientist was able to find this gene for sensing moonlight. So apparently this coral, I think, is probably both sensing temperature and moonlight. So it knows it's starting to get cooler because it's Australia, so it's starting to get warmer in October. And there's a full moon, so they can actually sense that. And what would be the benefit to all these coral species all spawning at the same time? Take a second and think about that one. So I, as well as other scientists, have come up with a couple different ideas. First of all, that maybe there's just something about that time of year that's best for, hatching your offspring, for reproducing. Maybe there's a lot of food in the water. Maybe it's just the right temperature. Maybe the currents are right to bring them back to the reef. There could be all kinds of reasons. Or maybe it's just that if they all reproduce at the same time, there's going to be so much sperm and eggs in water that the predators aren't going to be able to eat them all. And so it makes it more likely that some of the eggs and sperm and larvae are going to survive. Why wouldn't increasing fertilization success be a reason for doing mass spawning? What do you think? If you think about it, we're talking about many species of coral. So there's sperm and eggs from lots and lots and lots of different species of coral, all being produced in this one night. Sometimes maybe a little bit different in time or something, but often all at once. And so, because there's so many different species are producing at once, the likelihood that your sperm is going to meet the egg of someone else that's on the same species of yours maybe isn't that high. So actually, mass spawning probably doesn't really increase fertilization success that much. One species all did it at the same time, yes, that would increase fertilization success, just like those fish that we just saw did. But a whole bunch of different species? Probably not. Okay, so let's watch a little bit of mass spawning of acropora corals in class. So here you can see the corals spawning, the eggs and sperm starting to come out. And you can tell it's acropora because it has that polyp at the edge of the tip of each branch. They're starting to spawn more and more, and you can see it in the water. Oh, look at all that eggs and sperm. So much. And it's all rising, and it's moving in the waves. Remember they're buoyant, so that's why they're rising. And here you can see, I think this is actually a different kind of coral. Certainly different proper. And you can see at a different scale just how much there is in that water. And then just even when you get away from the coral, look at how much sperm and eggs there is in the water. It's so cool. Okay, that's probably enough. Oh, and then at the surface, you can see it's all rising to the surface and making that thing that looks like an oil slick that I talked about. Okay, if you want to watch this video, it's on refid.org. Look at mass spawning. You'll find it. Okay, so all those different strategies that we just talked about, brooding, broadcast spawning, gonochoric, hermaphroditic, corals do all of it. So this kind of weedy coral, Poecilopora daemicornis, it's a brooder, and most of the acroporas are broadcast spawners. So actually most corals are gonochoric broadcast spawners, 63% of them, but there are definitely some corals that do every strategy in the book, including ones that are not on this graph, like asexual reproduction. So I just wanted to show you here a couple photos I have of reproductive events. So here's a sea cucumber that's spawning. It's really cool. I just went out snorkeling out on the reef and I noticed suddenly all the sea cucumbers were standing up on one end and putting out this white stuff. So they were all spawning all at once, and it was in the middle of the day. It was really, really cool. This is at Midway a couple years back. And then another time I was doing this deep dive on the fore reef of Midway, and suddenly we saw this huge swirl of these giant trevallies, which we call aluras, and these are big, big fish. They probably weigh as much as I do. They're probably maybe not quite as long as I am tall, maybe like 4 feet. They're big freaking fish. So to see hundreds of them in this huge swirl for mating aggregation was really cool, because I didn't even know they did that. So it can be really cool when you get to go out in the water. Okay, so fertilization success. How do organisms control fertilization success? For most broadcast spawning invertebrates, especially sessile ones that can't move, it's pretty low. It's like less than 20% for most sea stars, urchins, corals, tunicates, and many different habitats. However, fishes can have fertilization success of greater than 95% because they have those really sophisticated spawning behaviors, like the spawning aggregation we just saw in the video. There you go. So what controls fertilization success? Adult density. The higher the density, the more likely to have the ill fertilization. Aggregative spawning behavior, like we saw in the sessile grouper, definitely increases fertilization success. Spawning in synchrony, if everyone's spawning at the same time, that will definitely do it. If there's more sperm in the water, if the gametes are of good quality, they're not too old, they're compatible with each other, so with the same species, that's important. And if the water's moving correctly, so there's like a little bit of turbulence, so things are, bouncing into each other, but the current's not sweeping them away completely. That's important. And also that the water quality is good and the temperature's right. There's a whole bunch of different things that play into this, but they're all probably pretty much what you would expect. Okay, so now we're going to be ready to move on to video 4. And we're going to talk about the Pentana larval.